This is a perfect example of a problem where it definitely helps to use the piece by piece and anticipation strategy. Otherwise, go ahead. If you read it straight through from here to here, I mean, even I would be confused. Sergio plans to paint the four walls of his room with one coat of paint. The walls are rectangular, and according to his measurements, each wall is 10 by 15 feet. He will not need to paint the single 3 by 5 rectangular window in his room and the 3.5 by 7-foot rectangular window. Sergio knows that each gallon of paint covers between 300 and 350 square feet. If only 1 gallon cans of paint are available, which of the following is the minimum number of cans of paint Sergio needs to buy to paint his walls? Again, most people who read this, I mean, unless you're some sort of genius, it's going to be confusing. They're bombarding you with numbers and figures. Four walls, 10 by 15 feet, 3 by 5, 3.5 by 7, 300 to 350 square gallons, minimum of 1 gallon or 1 gallon cans. So again, let's take it piece by piece and use the anticipation strategy. Sergio plans to paint the four walls of his room with one coat of paint. Okay, four walls. I'm gonna just draw a little figure of four walls. Okay, the walls are rectangular. This is rectangular enough. And according to his measurements, each wall is 10 by 15 feet. Okay, when we're given a measurement 10 by 15, I'm going to anticipate that this is going to have to do with area. So if each of these are 10 by 15, what's the area? So 10 times 15, or 15 times 10, that's 150 square feet. Each wall is 150 square feet. And then I'm going to anticipate further. So what's the total square footage? 150 times 4. Which I believe is 600, but I'm using my calculator just to show you that you shouldn't do calculations in your head. 600. So there's a total of 600 square feet. We've only read 2 sentences and we've already have this much in terms of notes. We're just absorbing the problem piece by piece and we're using anticipation. So Sergio plans to paint 4 walls. Each wall is 150 square feet. All 4 walls together adds up to 600 square feet. He will not need to paint the single, okay, so here are the exclusions. So he won't need to paint the 3-foot by 5-foot window. So what's the area of a 3-foot by 5-foot window? 3 times 5, so that's 15 square feet. And the 3.5 by 7-foot rectangular window. So 3.5 times 7. 24.5 square feet. So the exclusions are, let's just add those up. 15, 24.5 plus 15, 39.5. So 39.5 square feet are excluded. He won't have to paint. Of this 600 square feet, 39.5 square feet will be excluded that Sergio will not have to paint. Well, let me go ahead and anticipate and say, okay, so what will he have to paint? Well, let's just subtract 39.5 from 600. 600 minus 39.5. 560.5. So this is what he will need to paint. 560.5 square feet. Sergio knows that each gallon of paint covers between 300 and 350 square feet. So 1 gallon, we know we have to paint 560.5 square feet. We know that 1 gallon covers anywhere from 300 to 350 square feet. If only 1 gallon cans of paint are available, okay, so we can only buy 1 gallon cans of paint. We can't split it up. So only 1 gallon cans of paint. Which of the following is the minimum number of cans of paint Sergio needs to buy to paint his walls? Well, if we want to know the minimum, we want to use obviously not 300, but 350 square feet because we want as much paint available per can to find the minimum. Now, if it said maximum, we'd use 300, but they're asking for the minimum. So 1 gallon of paint would cover 350. 2 gallons of paint would cover 350 times 2, which would be 700 square, which would cover 700 square feet. So 1 gallon wouldn't be enough because we have 560.5. We need more. We need 2 gallons of paint. So, which would give us 700, and there'd be more than enough left over, but we can't split it up. We only can buy 1 gallon cans of paint. So the answer is G, 2. Again, don't ever read long problems like this straight through. Go piece by piece, take notes, mark up your exam, and anticipate. I'll see you in the next video.